Got it? What noble gas comes before europium? Xe, yep, xenon. That takes care of the first 54 electrons. That was good to knock some of those off. And now we go to 55. That starts the 6th energy level. So we got cesium and barium are in 6s. There's 2 electrons. Now after 6s, we jump down from 56 down to 57. And this starts the 4f. The 4f overlaps 2 energy levels higher. So yeah, there we are in the 6th energy level, and now we finally get to 4f. 1, 2, 3, 4, 5, 6, 7. It would be 4f7. And that gets us to europium. I'm going to ask you to do one more. Would you take a second and do selenium, number 34? Selenium. Okay, this one's pretty easy. Noble gas that comes before selenium? Argon, yes? So we're just going to get that argon. And then selenium's in the 4th row, so we just finish it from there. 4s2. After the 4s is 3d, there's 10 electrons there. And then 4p4. How many unpaired electrons in selenium? 2, right. In that 4p would be like this. 1, 2, 3, 4. Yes? 2 unpaired electrons. All right. Easy enough, but how about this one? If I were to ask you to do the electron configuration of the sulfide ion. At first you see that it might look scary, but oh no, it's the same thing. What does that -2 mean? It has gained 2 more electrons, right. So you can write an electron configuration for sulfide, because sulfur when it's neutral has 16, therefore S with a -2 must have 2 more than that, 18. So if you know there's 18, you may have a conflict. 18 electrons. Could you just write this and be done? 18 electrons. Nope, can't do that. When you have something that has a noble gas configuration, you have to go to the noble gas before it. I don't make the rules. That's the way we do it. So it's got to be this, neon core, 3s2, 3p6. Yep, for any noble gas electron configuration, take the one before it. Now, what if you had a multiple choice question that said this? It said, you have the electron configuration neon core 3s2, 3p6. Which of these choices would this be the electron configuration of? A, argon. B, sulfide ion. C, Cl-1. D, K+1. E, all the above. So be careful. When you look at this thing, this can be the electron configuration more than just argon. Because ions that are around this would lose or gain electrons to have this configuration. This is a coveted electron configuration. Atoms want this because it's the configuration of a noble gas. So be careful when you're given an electron configuration and you're asked about what it is, what element or ion has that. Well, if ions can have it, you got to look at all the possible choices. Just be watching out for that. Okay, now I got one more for you that's tricky. We call it the ferrous ion. The OUS at the end of this thing, well, even the fer, the Latin name for iron is ferrum. So this would be iron. OUS just means that it's the smaller oxidation state. The ic would mean a higher oxidation state. So there's ferrous, which is a positive 2 iron, and there's ferric, which is positive 3. That's the same idea as when we named acids. We had nitric and nitrous, sulfuric and sulfurous. The higher oxidation state got the ic. Now, what you think iron plus 2's electron configuration should be is probably wrong. Unless you remember from when you learned this before. Your intuition says to go to the last term that has electrons in it and just remove 2 electrons from that. That's not the way we do it, though. Let's take a look at iron when it's neutral. Neutral iron has the configuration argon core, 4s2, 3d6. Yes? When it's neutral. So if you want to get rid of 2 electrons, you're going to assume you just take those and make it 3d4. Yes? No. That's not what we do. That's why I wanted to show you this one. Make a note for yourself over here. Transition metal ions, which this is. I'm afraid I can't even tell you why this is. Because when we learned the order of filling electrons, you were told, and I was told, that the D is a higher energy level than S. So we put the next energy level as S, and then we put the D in there. However, when we're removing electrons, you're always going to remove, from a transition metal ion that has D's filling, remove the S electrons first. Essentially, we remove the valence electrons first. Valence electrons are the outermost S and P electrons. So we're going to remove the outermost S electrons first. I will say, you don't ever mess with this noble gas core. Atoms are not going to remove electrons from that argon core. That's a very stable electron arrangement for those. Those are the inner electrons, they stay put. But the outer electrons can be manipulated. You do need to remember that, though, about the transition element. Yes? So what would be the electron configuration of Fe plus 3? Okay, so we got rid of the S electrons. Where does the third electron come from now? Well, you don't have many choices. You can either take it out of the argon core or the 3D. In this case, for iron plus 3, it's going to be argon core 3d5. If you need to take a third electron off of iron. So the answer to this one is this. Is argon core 3d6 is the iron plus 2. Iron plus 3 would be 3d5. You had enough? Is that good for today? Yes. Or we can keep going if you want to. So we'll have to take on periodic properties on Monday. Reading quiz Monday morning. Don't forget about that. Well, Monday afternoon, I guess. Somebody will take one Monday morning. But don't forget the reading quiz.